Manipulation. Hello, my name is Dr. Esther Trufan, and in this video, we will explore the quantitative literacy rubric focusing on the manipulation dimension. This is the AAC&U rubric for quantitative literacy, and today we will focus on the manipulation dimension. In chemistry, manipulation is defined as the ability to identify the proper calculations needed, organize appropriate data, and perform needed calculations accurately to solve a problem and communicate logical conclusions. The data types in chemistry labs are chemical formulae on the simplest side, then chemical equations, stoichiometry calculations, spectra, phase diagrams, titration curves, reaction energy diagrams, and much, much more. In the manipulation category, we're asking students to identify the solution, organize their data so that it fits the identified solution, and then apply it to get the correct answer. So, for example, when a student is asked to determine the density, identify the proper calculations needed, would ask them to identify density equals mass divided by volume. Organize appropriate data would require them to identify the value and unit associated with mass and the value and unit associated with volume. And then perform needed calculations accurately would require them to place the mass on top, the volume on the bottom, and correctly perform the division and include the correct units. How do we phrase questions that require students to demonstrate their ability in the manipulation category? Here are a few examples. Using the total mass of the mixture before and after the separation, calculate the percent recovery. Show your stepwise calculation with the appropriate units. Another question. Calculate the moles of hydrogen gas expected from the reaction of hydrochloric acid with magnesium. Use stoichiometry, appropriate units, and consider the significant figures. You can add as many clarifying components to this question as you wish. Make sure that you adapt it to the level of your students, whether they are in a freshman introductory level class, or pull back a lot more of that scaffolding in your upper level courses. This would be an appropriate phrasing for introductory and general chemistry classes. Our next example, using the calculated molarity of the stock solution, calculate the molarity of each diluted sample of a red food dye 40. Another task, calculate the concentration of the oxonium ion and determine the pH after 7.5 milliliters of a 0.1 molar sodium hydroxide reacted with the 15 milliliters of 0.5 molar acetic acid solution. And here is an example for organic chemistry. Use your TLC plate to calculate the retention factor values of each spot. For more examples of quantitative literacy questions integrated in chemistry experiment prompts, visit experimentium.org.